Today we're going to talk about the empirical formula of compound. By definition, empirical formula is simply the simplest ratio formula. Sometimes you've got a situation where your simplest ratio formula can actually be your chemical formula. In this example, C6H6, you'll notice that we reduce the subscripts to their simplest ratio 1 to 1, then we get CH. So C6H6 tells us how many carbons and how many hydrogens are in the compound. That's the molecular formula. When we reduce that to the simplest ratio, we get CH, and that's the empirical formula. All right, now there are a few compounds that have molecular formula and the empirical formula being the same: water, carbon dioxide are a couple of examples of that. One of the things that we need to be able to do is calculate the empirical formula. So the steps we go through are fairly straightforward. First, we make a mass assumption. Second, we take the number of moles of each of the elements, and then we determine the lowest whole number ratio. And that's going to be our empirical formula. So here's how this works with an example. All right, so what's the empirical formula for a compound which is found to contain 92.3% carbon and 7.7% hydrogen? All right, so the first thing is, because we're dealing with the relative percentages of these elements in here, why not assume that we have 100 grams of the sample? And that way we can use the percentages as actual masses. And as a result, then, we can use those masses and the molar mass to figure out the number of moles. Okay, so that's the way we're going to go about this. So assume 100 grams of the compound, and that means we have 92.3 grams of carbon and 7.7 grams of hydrogen. All right, so let's take the carbon first. Figure out the number of moles is mass divided by molar mass. So 92.3 grams divided by the 12.012 grams per mole. And that gives us 7.683982684. You'll notice that I kept all the decimal places, and that's because I don't want to round too early. I want to save the rounding till the very end. Then for the number of moles of hydrogen, same calculation. And we end up with two numbers that are very, very close to each other. Right? And so we can tell pretty much on the get-go that if we round this to the correct number of significant digits, we pretty much got a 1-to-1 ratio here. That's fairly straightforward. And that's the reason you don't want to round too early, is because if you round, you introduce errors, and then sometimes you can't justify the ratios that you might get. All right, so this one will give us an empirical formula of CH as a result of this. Now, the problem is that, okay, so how precise do these numbers, or how close to these numbers have to be in order to be able to round? So numbers like 6.81 and 18.3, can you round that to 1 to 3 or something like that? And so we have some issues that we have to work out here, and some generalities that we have to make, and what's acceptable to round and what's not. So basically what we want to do when we have a situation like this, we want to reduce one of these to 1. If we can do that, then it might be easier to see how we round these numbers. So the 6.81 then, if I divide both of the subscripts by that value, the smallest one, then that reduces the smallest one to a 1, and it'll give me other values for the rest of them that maybe I can reduce to something, or it'll be a multiple of something that'll be. All right, so let's try this example here to illustrate this. We have phosphorus reacting with oxygen, gives us a compound that contains 43.7% phosphorus and 56.3% oxygen. What's the empirical formula? Okay, so let's go through the process again. First, we assume that we have a 100-gram sample. Then we figure out the number of moles of phosphorus from the mass, 43.7 grams. And we get this 1.41 in a bunch of decimal places. Then we figure out the number of moles of oxygen. And we get 3.51 in a bunch of decimal places of moles. All right. Now, oh, by the way, your calculator has a memory function. And most calculators, most scientific calculators can have upwards of 5 memory places. And so it's a good idea to learn how to use those. I'll try and incorporate a tutorial that illustrates how to use your memory locations, maybe with this video later on. Okay, so what we do is we write down our subscripts. Okay, so this is the part I would write down first. And we'll notice this is the smaller one. So what I'm going to do is I'm going to divide by the smaller one, which is going to reduce this value to a subscript of 1, and this other one to a value of 2.49 for a bunch of decimal places. All right. Now, one of the things that we need to recognize here is these decimal places and what their fractional comparisons are, or fractional equivalents are. So if we notice this is like 0.49, 0.49 in a bunch of decimal places is really close to 0.5, right? 0.5 is a half. And so this number here now is very close to 2.5. Right? So if I double this, I get a whole number, right? Which is what I want. And so that's the idea here. So now if I take these two values and I double them, then I get P2O 4.9888. And then so this number here now is close enough to 5 that I can round it. Essentially, the rule that we want to follow for rounding is that if we're within 0.0 something of a whole number, we can round it to the whole number. More than that, you might not be able to. Okay, you might be far enough that you may have to do some more calculations or more simplifications. But this number is very, very close to 2.5, and so we can pretty much round this to 5. And so this becomes P2O5 as our empirical formula. All right, so how do you know when to round? Well, this table gives you kind of the decimal values and the multiple that you can use to get to a whole number. Right? So we just talked about 0.5. Right? We multiply by 2 because 0.5 is a half. Right? Well, numbers like 0.25 and 0.5 and 0.75, those are quarters. Right? So if you multiply by 4 at 0.75 and 0.25, then you can get to a whole number. 0.2, 0.4, 0.6, 0.8, those are fifths. And so 1/5, 2/5, 3/5, 4/5, so on. And so those values can be multiplied by 5. 0.33, 0.67, those are thirds, right? 1/3 and 2/3. So if you multiply by 3, 0.17 is very close to 1/6. So if you recognize these decimal values, then it's easy to figure out what multiple I should multiply to get to that whole number that I need. All right, so here's homework for today. Try some of these again. You don't really need to do all of them, but there they are. If you're just not getting it, some of you will have to do all of them. But there's lots of practice for you. Go ahead and try those.